If you've ever been told that simple molecular substances have weak bonds, I hate to break it to you, but that's not actually true. And it's one of the biggest mistakes students make in exams. In this video, we're going to clear that up. I'm Caroline, a teacher of 10 years, helping you understand GCSE and A-level chemistry. I'll take you through what simple molecular substances are, what's going on between the molecules, their properties, and exactly how to tackle those exam questions without falling into the classic traps. Stick around because at the end, we're also going to do a true-false round to test your understanding, and trust me, a couple of them will catch you out. So let's start off with how to spot simple molecular structures. So if you are reading a name or a formula, then in order to work out if it's simple molecular, you're looking at the combination of elements in there. So you are looking for non-metals. Now that could be, for example, carbon dioxide, carbon and oxygen, two non-metals, carbon and hydrogen for methane, but it could also be things like hydrogen, H2, nitrogen, N2, because that is an element, but each of those hydrogen atoms is a non-metal. So it's any combination of non-metals is going to be simple molecular. Your key word, therefore, that you're going to use throughout your exam answers is molecules. And only for this structure type can you use the word molecules. And what are they? They are quite simply atoms joined by covalent bonds. And you can see that in the diagram. So the blue and the purple spheres, those are our atoms, and then they're joined by covalent bonds. Covalent bonds, note this down, are a shared pair of electrons. A shared pair of electrons. And covalent bonds are really, really strong. Okay? Now, then we have to think about what's in between the molecules. There are no bonds. There's no lines there in between those two diagrams that you can see, those two molecules. So what instead is weak forces of attraction holding them together. So strong bonds within the molecule holding the atoms together, but only weak forces between the molecules. So that's what they are. Now let's think about some common mistakes. So the first mistake is not quite understanding what a molecule is. And a molecule is when two or more atoms are joined together. So again, that could be a molecule, N2, S8, etc., O2, oxygen, or it could be a compound. The second mistake that often crops up here is getting confused between forces and bonds. Okay, there are three types of bonds: ionic, metallic, and covalent bonds. In simple molecular substances, we find covalent bonds and they are very strong. But in between the molecules, we only have weak forces. And therefore, if you change the state of something that is simple molecular, i.e., if you go from solid to liquid, melt it, if you go from liquid to gas, boil it, then you do not break the bonds. I cannot emphasize this enough. It is the biggest mistake by far when it comes to GCSE chemistry and A-level chemistry. You do not break the bonds. Instead, what happens is you overcome the weak forces between molecules. You put in a small amount of energy to overcome the weak forces between molecules. I've highlighted those words because those are the exact words that you are going to see in mark schemes. Okay. Also, don't just say overcome the weak forces, break the weak forces, because that doesn't show that you understand where they are. So it's weak forces between molecules. So let's explore this a little bit further by giving you an example. So imagine that you are making a cup of tea. You fill up the kettle with water, you flip the switch, and then that water boils. It turns from liquid to gas, and you see the water vapor coming out the kettle, and you end up with hot water, right? So if you were to break the bonds in water, then you'd end up with puffs of hydrogen and oxygen gas coming out of your kettle, not hot water. So in order for you to get hot water and make your nice cup of tea, you only have to overcome the weak forces between the water molecules. If you break the bonds between the atoms in the water, then you don't have water anymore. You have hydrogen and oxygen. So if you make that classic mistake of breaking bonds in simple molecular substances, it's very bad for tea drinkers because you never get your nice hot cup of tea. So we are overcoming weak forces, not breaking bonds. Now, let's use what we know about simple molecular substances to explain the properties. So we would describe their melting and boiling points as low. And the reason comes right back to those magic words we've been saying throughout, because little energy is required to overcome the weak forces between the molecules. Then let's think about conductivity. So conductivity refers here to electrical conductivity. Do these substances conduct electricity? Now your answer is no, they do not conduct electricity. And let's just backtrack a second. What do you need for something to conduct electricity? Two things, something that can move and something that can carry a charge. So let's consider what we've got here. Well, molecules, which are made of neutral atoms, are neutral. So therefore, by saying molecules are neutral, we are saying we do not have something that can carry a charge. So there is one version of that explanation that you can give in an exam answer. Molecules are neutral. If you want a more general answer that would apply to perhaps other substances that do not conduct electricity, then you could say, because there are no free ions or electrons to carry the charge. But if you are going to use that explanation, it must be in its full form like I have given you here. Because you can't say, for example, because there are no free electrons to carry the charge. Because what about ions? Okay, we're saying we have something that can move and something that can carry a charge. The two charged particles generally in substances are ions and electrons that are free to move. Okay, so be careful with that one. If you are going to use it, it needs to be in its full form. No free ions or electrons to carry the charge. Hang on. So you may be aware or have been taught, hopefully, that water conducts electricity. And yes, that is true to the extent that if you open your tap and water comes out, that water does conduct electricity. Okay, don't take your toaster in the bath, right? But pure water doesn't. So if you have only water molecules present, that's what pure means, then that does not conduct electricity. So the water that comes out of our tap, what must be in it as well that means that it can conduct electricity? See if you can think before I share. It's because there are dissolved ions in the water that comes out of our tap. And that is why it conducts electricity. Those free ions can move and carry a charge throughout the water. But the water molecules themselves are neutral. And if you had pure water, it would not conduct electricity. Okay, let's test things out now. So I promised you some true, false questions. These are amazing for really drilling down into your understanding. So try and be careful here. They are designed to catch you out. We're going to go through each statement, see if you can answer for yourself whether you think they are true or false before we dive into what they actually are. So our first one says, nitrogen, which you can see there in pink on the right-hand side, is a gas at room temperature because the bonds between the atoms are weak. Is that true or false? It's false. Because this falls into that trap of very bad for tea drinkers. You do not break the bonds in simple molecular substances. Instead, you overcome the weak forces between the molecules. Second one, nitrogen has a higher boiling point than hydrogen because there are more bonds to break. And you can see that there. The pink nitrogen has 3 bonds, a triple bond, and the hydrogen only has 1 bond. Is this true or false then? It is false.
Because again, it falls into that trap of breaking bonds. There are not more bonds to break because you do not break them. Instead, nitrogen does have a higher boiling point, but that is because there are more weak forces between the molecules. So a little bit more energy is required to overcome them. And then finally, hopefully you're twigging onto this now, see if you can catch this one. Nitrogen has a higher boiling point than hydrogen because there is a triple bond between the atoms instead of a single bond. Again, false. Because we don't break those covalent bonds, we overcome the weak forces between the molecules. Okay, next one. Carbon dioxide doesn't conduct electricity because it has no free electrons to carry the charge. True or false? False. It is false. Because it doesn't quite include everything. Electrons are not the only charged particle that could conduct electricity, that could carry the charge. There is another charged particle called ions. So if we want to make this a true statement, then we need to say something like, carbon dioxide doesn't conduct electricity because it has no free electrons or ions to carry the charge. Or you might say because carbon dioxide molecules are neutral. Next one. The formula H2O means the ratio of hydrogen atoms to oxygen atoms is 2:1. Now, usually for most exam syllabuses, for this we would say false, because the formula H2O is referring to a molecule of H2O. And in one molecule of H2O, you have 2 hydrogen atoms and 1 oxygen atom joined together by covalent bonds. So yeah, we'd say that is false. And your actual answer is the formula means we have 2 hydrogen atoms, 1 oxygen atom joined by covalent bonds. Next one. That is a repeat. Next page. Buckminster fullerene C60 is simple molecular. This one catches out a lot of people. What do you think? It's true. It's true. So the fact that it says C60, that's your clue. Okay, a lot of times we're used to thinking of carbon as giant covalent when it's graphite, graphene, and diamond. But C60 tells you there is a specific number of atoms. Now, yeah, that means it's a bigger molecule than some of the others we've maybe talked about so far, but it is still a molecule, just a slightly larger one. And then finally, serotonin structure, which you can see there on the left-hand side, is only one molecule different from amphetamine structure, which you can see on the right-hand side below the table. Is that true or false? It's false. That sentence is nonsensical. It doesn't make sense because on the left-hand side, you have one molecule, and on the right-hand side, you have one molecule. What that person is trying to say there probably is that the molecules are very similar and that they only are different by a few atoms or groups of atoms. But you can't say it's only one molecule different. If it's only one molecule different, it is a completely different molecule. Okay, so a better way to express that is to say serotonin structure is very similar to amphetamine structure with a few different atoms or groups of atoms. Okay, let's recap. So we've learned today that molecules are atoms joined by strong covalent bonds. Simple molecular substances are all of the non-metals joined together. There are weak forces between the molecules, which is why they have a low melting point and a boiling point. And we do not break the bonds when we change the state of a simple molecular substance. We only overcome the weak forces.
Thanks for watching. If this was helpful, then make sure you hit subscribe. There are new GCSE and A-level chemistry videos released every single week on Tuesday. Thanks for joining us, and I'll see you in the next video.